I recently posted a new quiz on the website called Odd and Even Functions, and I just wanted to do a video to go over all the background related to that quiz. And I'll provide a link in the description to that quiz. So to start with, we have the definition of an odd function, which is f of minus x equals minus f of x, and that will have a graph that looks something like this, that it'll go through the origin, and it'll have this kind of symmetry where if you rotate this 180 degrees, you get back the exact same function, the exact same graph. And then for an even function, we'll have this property where f of minus x equals f of x, and it's going to be something like this, where it doesn't have to go through the origin, but it has a symmetry around the y-axis. So let's look at some basic examples. So to start with, if we have f of x equals x squared, that's going to be even. It looks, you'll notice this is just a parabola, will look a lot like this. But now to verify, whenever you want to verify if something's an even or odd function, we can just go back to the definition and we can take this function and plug in minus x. So if we square minus x, we just get back x squared, which is the same as the original function. So it has this property that f of minus x equals f of x. And similarly, we could look at, I have a hard time saying that, we can look at f of x equals x cubed. Its graph is going to look a lot like that. Now we can do the same test, but we're going to test for odd. So what we'll do is we'll plug in negative x. So if we substitute negative x in for our function, this is just going to be minus x cubed. But that is the same thing as this function, but times minus 1. So this is going to be minus f of x. So I think those are the simplest examples. Let's look at something we're going to kind of build up to gradually more complicated examples to just get a better understanding. So for our next example, we're going to look at, what are we going to look at? So f of x equals x squared plus 4. Now the graph of this is going to look kind of similar to that, but I could shift it up. So the graph of x squared plus 4 is just going to be something like this. That's a poor drawing, but this is the shift up 4. But we still have the symmetry around the y-axis. So it's still the same on both sides of the y-axis. So this is going to be even, but let's verify it. If we plug in minus x here, we'll try to use this even property. Minus x squared plus 4. Squaring this is just x squared plus 4, and that's the same thing as this function f of x. So this is even. And you may want to, you could try, you also notice that it's not the same as the odd definition, right? Because if it was odd, we'd have to get back minus f of x. I actually was going to do, let me skip kind of ahead. So let's do something else. Let's just look at f of x equals 4. So what's that graph going to look like? It's just this is our, just to clarify, it's the axis. So this function is going to look like just a straight line, horizontal, at y equals 4. But notice that still has that symmetry around the y-axis, right? So that looks like it's going to be an even function. If we do this same thing, if we say f of x equals 4, and then we want to see what's f of minus x, well, that kind of doesn't make sense, but if you do it, it's just 4, so that's f of x, so this property holds. And so f of x equals 4. Now what I wanted to pull from that is, notice that initially we had f of x equals x squared, which was even. We have f of x equals 4, which is even. We added two even functions together here, and we still have an even function. So that's an important property right there. Now we could real quickly look at f of x equals x to the 5th. This is going to have a similar graph to this. It starts getting steeper than x cubed, so it's going to be a little it's crushed down, but it's kind of the same basic shape. And so it doesn't take too much to show. This is very similar to the x cubed case, but this is going to be minus x to the fifth, which is minus f of x, showing this is odd. What I really wanted to show though was, what if our f of x is x to the fifth plus x cubed? We already did x cubed earlier, so we're just adding two odd functions. Let's do our test. So we'll have minus x to the fifth plus minus x cubed. This is going to be minus x to the fifth, just getting the fifth, raising that to the fifth power. Same thing, if you could separate, like, write this as like a minus 1. If we cube that, this is going to be minus 1 x to the third. So what we could do is we could factor out a 1 and write this as minus x to the fifth x cubed. But you notice that's actually just minus f of x. So what we did there was we verified when we add two odd functions together, we still get an odd function, and this property holds. So really, the funny thing is, no matter how complicated these seem to get, you can always go back to the definition and plug it in. It's useful to know that when you add two odds, you get back an odd, you add two evens, you get an even, but you can always go back to the definition. Next, I want to look at f of x equals, and this one's getting a little interesting, x cubed plus 4. And notice from earlier we said this was an odd function and this was an even function. So now we're adding an odd to an even. Let's look at the graph real quick. It still has the same shape as this, but it gets shifted. So it's something like that, with this point being 4. So it's shifted up 4. So it has this shape, it has this kind of symmetry, but it doesn't have that symmetry around the origin. Notice so let's just use the definition and we'll look at f of minus x here. So we'll have minus x cubed plus 4. Then we'll simplify this, pretending like that's like a 1 right there. And this is going to look like minus x cubed plus 4. Then what we would like to do, like, we can't really factor out a negative 1. I mean, we could write this as minus x cubed minus 4. But that's not the same as minus f of x, right? Because f of x is this. So it doesn't hold as an odd function, but this is also not equal to f of x, right? Because f of x is this and this is different. So this is actually a case where it's neither odd or even. It's just important to notice that functions don't have to be odd or even, they can be neither. And in this case, when you add an odd function to an even function, you get something that's neither. Let's look real quick at a couple of trig functions. So f of x equals sine of x is odd. And you may know, this is kind of circular because I think we say this property, the way we do it is by saying it's odd. But if you have f of minus x, then if we have sine and minus x, this is the same thing as minus sine of x, which is going to be minus f of x. So that's odd. Then here, for cosine of x, if we have f of minus cosine of x, handwriting's getting sloppy. This is actually the same thing as cosine of x, which is f of x. So this is even. But then let's actually show it. There's a few ways you can see this if you actually look at the sine curve. I just don't want to draw it because my sine curve is going to be a mess, or sine or cosine, the full curve. But if we look at, let's look at the unit circle. So let's just take a couple of points. Like if we notice, if this is pi over 3, the cosine, that's a terrible radius right there, but let's deal with it. So like we have this x value for pi over 3, but then notice at negative pi over 3, if it's right here, you'll notice I'm not the best drawer, the most accurate handwriting or whatever. Like looks terrible. Okay, so I'm not making my point very well, but basically we're saying for the same, we end up at the same x value for minus pi over 3 as pi over 3. Similarly, if we go to, let's say this is 5 pi over 6, the cosine here, I didn't even say what it was. This x value is 1/2, and it's 1/2 here. So we have our negative input, and we get back the same value. We get a half and a half. Then similarly over here, if we look at 5 pi over 6, or negative, this will be our negative 5 pi over 6. This x value here, in both cases, is going to be square root of 3 over 2. I'm sorry, minus square root of 3 over 2. So we're showing that this is even just because we can put in a negative input and we still get back the same answer. Then we can do the same thing for sine. If we look at sine of pi over 6, this is going to be 1/2. But then if we look at sine of minus pi over 6, this is also going to be 1/2. No, sorry, this is going to be minus 1/2, which is this definition of an odd function. We put in the negative input and we get back a negative answer, whereas with the even function, we put in the negative input, we get back the exact same answer for f of x. Next, we can look at multiplication on the left here and division, and it's really pretty intuitive. And then the relationship, really division and multiplication work the same way. Like if we have an odd function times an odd function, we get an even function. But if we have an odd function divided by an odd function, we get an even function. This is pretty easy to see. Like if we have, so let's say, okay, we know our odd function is this, but let's use a different variable. So if we have a second odd function, that's going to be, we'll call g of, our second odd function is going to be g of x, then g of minus x is minus g of x. So then if we have the multiplication of odd function f of x times g of x, then we can just kind of go back to the definition and plug in our negative value, like so. But then f of minus x is going to be minus f of x. Then g to the minus x is going to be, let's be careful, minus g of x. But then these minuses multiplied together are going to be a plus, and we're back to f of x times g of x, showing that odd times odd is even. So similarly, I don't want to go through every one of these examples, but you can do that the same way, and you can come to each of these. But what I'll do is I'll actually do some specific examples so we can see it in practice. So let's say our f of x is tan of x, and we want to know if this is odd or even. So let's rewrite f of x. We'll write our tan x as just sine x over cosine of x. And then when we do that, we can see we have an odd function over an even function. So then let's see what happens if we take, let's look at f of minus x. We'll plug in sine of minus x, cosine minus x. Because sine's an odd function, we can rewrite this as minus sine of x. Because cosine's an even function, we can write this as cosine x. But then what we have here, this is just tan, so we end up with minus tan of x. But that goes back to f of x, so we just have minus f of x. And so this is actually the definition of an odd function. So tan is odd, but that also means that odd over even is odd. Next, let's do f of x equals cosine squared x. This one might seem a little more obvious, but we have an even function times an even function. We have cosine x times cosine x. So let's look at what happens when we look at f of minus x. So we'll have cosine minus x times cosine minus x. But because they're each even functions, we can rewrite each one as cos x times cos x, but this is just cosine squared x. which is f of x. So that is the definition of even. Then for one last example, we're going to look at f of x equals x cubed times sine of x. So we have an odd function times an odd function. Now let's look at f of minus x and see what happens. So we'll plug in our minus x here, sine of minus x. So then multiplying this out, we end up with minus x cubed. Here, because sine x, this is a odd function, we can pull out the minus sign. So we'll have minus sine of x. But then minus times minus is going to be positive, and we're back to x cubed sine of x, which is just our f of x. So that shows that when we have an odd times an odd, we end up with an even function. And again, they all work the same if we had it as a fraction. So like if we just real fast, if we had x cubed over sine x, odd over odd, again, this would be even. You'd get the same kind of cancellation because you're going to have a negative sign over a negative sign. And so you can kind of just play with the combinations, but you can always go back to the definition and show how it works yourself. So again, these problems, and this all came from my quiz on even functions. I'll provide a link in the description. Hope that helped.